JavaScript Web Tokens in .NET Core, along with a short demo. As always, you can find the source code for the demos up on my GitHub, and you can read more about JWT tokens and what they're used for and keep up to date on all of the latest information, security vulnerabilities, etc. Why a JWT? Well, at the bottom of the well, it's because they're so flexible. Because they're plain text that you can base 64 in code, which covers pretty much any situation that you might find in passing them around, they're incredibly handy. And they're also relatively compact compared to other token types that are popular. You can validate a JWT without having to do a key exchange. The JWT itself contains the bits required to find out if the JWT has been tampered with. And if you trust the issuer of the JWT, which you can check by cracking it open and seeing who the issuer is, then you can pretty much trust the token. They have the possibility of expiring, so they're very flexible in that way. They can hold identity, they can hold name-value pairs, otherwise known as claims, so you can pack them full of, for example, user metadata, like full name and email address, user ID, that sort of thing. And, they're very widely adopted. There's lots of great things built into ASP.NET, but JWTs are really interoperable across .NET, JavaScript, Java, Python, Perl, believe it or not, Go, Rust. Name the programming language if there is a library for it. And by the way, you can find a list of those up on jwt.io. You can pretty much use that JWT as a token exchange across all those different stacks. So that's a very powerful thing.
Okay, here is the demo method of the test JWT helper test class. I like MS Test, so that's what these are. And to sort of show you how JWTs are constructed and validated, here's an end-to-end test that creates a JWT and then validates it, and we're going to show you what you can get out of it, as well as salt in some useful things along the way. So the best way to explore this is to actually set a breakpoint and then just step through the test and step into the code to see what the JWT maker is making. So the first thing we're going to do is we're going to create an identity. And for the .NET libraries involved in this, the identity has to derive from II identity. So here is my little JWT identity class that really only supplies the username as a parameter. That's the entire interface for II identity. And I'll point out that you can use any identity that derives from II identity. So you can use a claims identity, you could use a forms identity, you could use a Facebook identity, you could use whatever kind of entity class you have laying around, as long as it implements II identity. So we're going to create an identity called user2 to use with this. And then we're going to create a secret. And this is important. This little utility makes a random secret of 256 bytes. And that secret is used to effectively encrypt and validate the token. So in real life, you would want to create this secret, put it in somewhere like Azure Key Vault or HashiCorp Vault or some other secrets manager, rotate it at intervals, but keep a history, and go get the secret when you need it from that source. But for the purposes of this demo, we're just going to make a random secret. And all this is doing is using the cryptographic randomness library to make a byte array of 256 bytes. And we're going to initialize our little helper with that secret so that it's sort of universally available. And then we're going to create a creation request object. And we're going to give it an identity, an audience, an issuer, an expiration. And notice that the expiration is an expression of a time span. That's a best practice. That way, in the moment when the token is created, the expiration will apply from UTC now to however long the time span is. We're going to build a claim list. This can be anything you want. In this case, I am adding useful metadata that I'd want to have available to me when I parse this token. And in this case, it'll yield an email, a full name, and an org, along with our username that we set up here we set an identity. And then once we have created the request object, we will create the actual JWT itself. So we're going to step into the creation process so you can see what .NET classes are being used to create a JWT. So we have a bunch of validation, and the first thing that happens is we generate a symmetric signing key from our byte array secret, and from that we say, okay, well, we need to create some signing credentials, which we're going to take our key that we created, our symmetric key, and we are going to tell it what algorithm is going to be used, in this case, HMAC SHA-256, and the resulting credential object will be useful for doing the cryptography on our token. And we're going to create a security token descriptor. And so this is basically the payload of what will be in the JWT itself. So we're going to set our subject equal to the identity we created and our claims bag above, and that's called the claims identity. So now we can take any identity, add the claims to it, and get a claims identity, and that's a desirable thing for a JWT. We are going to set a not before, so date time now, and we're going to set the signing credentials equal to the credentials we set above. We're going to set an issuer. We're going to set an issue at. We're going to set an expiration, which is UTC now plus our time span, and an audience. So once we have set those things, then we are in a position to then invoke our handler to create a token. And it's worth noting that our handler is of type System Identity Model Tokens JWT Security Token Handler. And that is the primary helper class that's going to let us do things with JWTs. And in this case, in the constructor of our helper, I stood one up. So this is going to get us a plain token. And if we go look at it, you can see that it's indeed an object that is hierarchical, that contains all of the things that we stuffed into it. And we can expand those properties and take a look at them. And it includes an encoding header and so on. But we still don't have an honest-to-goodness JWT yet. This is still an object. So what we want to do is call write token on the plain token we generated, and it's going to take that object and it's going to create something that corresponds to the RFC, which is a 3-part JWT token. And if we look at it, you can see that it very much looks like what you'd expect out of a JWT token. It has 3 parts separated by periods. So it's got a header, a body, and the cryptographic signature at the end, right? That's the format of a JWT, is 3 parts separated by a period. And we're going to go ahead and return that back to our test, and we can write that out. Notice that this is the pure form of the JWT. If you're passing it around, You probably want a base 64 encoded just to make sure that there aren't any verboten characters in the thing that you're passing around. It doesn't happen very often, but when it does happen, it will definitely cause your code to misbehave. But in this case, I'm just going to go ahead and use the raw token. So we're going to call helper validate, and we're going to create a validation request consisting of our audience, our issuer, and the token itself. And we'll step into that to see what it does. And you can see that it does the usual boilerplate checking. And it makes a response object that we're going to pass back to the user that contains all of the things that are parsed. We are going to recreate our signing key using the exact same secret. I can't tell you how important that is. And we will use that in our token validation parameters class. So we're going to put in an allowable clock skew, which is how far off from the time, basically plus and minus over under on how sensitive we're going to be about expiration. We're going to put in our issuer and our audience that we use to create the token and the signing key. And then, of course, we will pass in the token and the token validation parameters, and out will come a validated security token or an exception if they don't match. And if we look at this, you can see that once more we have an object which contains a lot of the same initial fields that we put in when we created the token. We're going to go ahead and do a little validation, and then we're going to populate our response object so that it's got the information about the token that we want. And now that we have that, we have in the response, we have a little business rule for whether or not it's a valid response or not. We're going to go ahead and output that to our test. And likewise, we're going to spin through our claims and emit those. And the upshot of this is if we look at the output from the test engine, that to the debugging surface, you can see that we generated a 309 character JWT token, that we then decoded it and got back the expiration and all of our claims. Notice that it added additional claims besides the ones that we explicitly put in. So this is the claim that represents identity, and these three were the claims that we added by hand. And then these claims are the claims that are automatically added by the .NET library because we need an NBF, an expiration, IT, an issue, and an audience. So what's the deal with issuer and audience? Issuer right now is set to self, and audience is set to test, and those are just for testing purposes. But really, issuer should be the DNS or name of your organization. So in my case, I really should use blitzkriegsoftware.net because that's who I am. And so somebody who gets this token can then look at the issuer and go, oh, it's from blitzkriegsoftware.net, and the token hasn't been tampered with, so I'm pretty sure that's who it's from, and they can make a decision about whether or not to trust it. The other thing is the audience. So what's audience for? Well, let's say we get a JWT and it's from blitzkriegsoftware.net, and we're happy about that. But the token is being used to query a method that I am not allowed to use as my user. And so I could compare the user and the audience that the token is for against the audience and the user that my method expects or allows. And I can use that to either accept that call or reject that call with an unauthorized. Setting a real issuer and a real audience can be very helpful. Audience can be whatever you want as long as both ends of the sender and the receiver of the JWT agree on who are the trusted issuers and what are the trusted audiences, and for each audience, what functionality are they allowed to interact with. And that's pretty much all there is to having a ability to generate a JWT token with any identity mechanism that you want, and you can then use it for your own nefarious purposes. So you could take, for example, an OAuth token and validate and parse it, and then your system prefers JWT. So you could then create a JWT that has the important bits out of the OAuth token that you want and use that as your internal token. And if you're using ASP.NET, there are lots of built-in libraries and easy to set up things as part of Startup CS, and you can use the authorize attribute and optionally include the audience. And so assuming that your token is from the correct issuer, on a method by method basis on, say, a web API or a web page in ASP.NET, you can decide whether or not to let people in or not. So this is a simple and powerful mechanism, and all we've done is wrapped it up and kind of constrain that from being wild open to having some very specific business rules. A note on biddedness: 256 is generally a good biddedness. It's a trade-off between how many more bits we add to the raw information in the JWT to the level of effort it takes to figure out how to tamper with your token. And if tokens have fairly short-lived expirations and you have a token renewal process or a token invalidation process, that again, ASP.NET has some things for that. You can use that, and if you're doing it in your own internal systems, you can have whatever business rules you want. And the origin of this is I was trying to figure out how to build a JWT to interact with some Node.js stuff I was doing, and I was banging around trying to figure out which of the various token types would be useful across all the stacks, and what is the most interoperable appears to be JWT token.